Thank you all for joining. I'm Ellie. I'm a senior software engineer at Trainline, and today I'm going to talk about our OpenSearch journey when serverless goes wrong. So in this presentation, I'm going to share our journey of navigating the unexpected journey with OpenSearch serverless, and I'm going to highlight the challenges we faced and also some key takeaways. So, it's not going. Okay. So in this presentation, I'm going to take a look at our situation and the problem that we have with a specific service, the challenges and future requirements, and then I'm going to have a look to our solution and take a look a bit how OpenSearch is working under the hood. And then, selecting the right infrastructure, we are going to take a look at the serverless and OpenSearch serverless and provisioned architecture and compare them, and finally some takeaways. So, to begin, we all have this problem, a familiar story, that some critical service start to not performing quite well under the pressure and under the load. So, as the demand grows for these kind of services, we all know that they are going to face some latency, some performance issues that can be critical for us for that service. And also, as these services are dependent to some other services, what will happen, any issue to that service is going to cascade more and can bring the issue even bigger, and any problem to face like a bigger outage. And we are going to deal with the frequent slowdown, outages, and also sometimes we need to have some expensive workaround to just make things work. And you know what is worse? Sometimes the worst things happen is going to have like a SQL database at the heart of these services, which they are not working well for our scale. So, but this is a familiar story, but what is about our situation? So the situation for us was about a specific service, which was a search-heavy service, which built on SQL. And we want to expand and scale this service, and it wasn't working so well. And that was our situation, the problem that we are going to have a look and solve. But first, let's have a look at what are the challenges that we face with that service. So, we have some outages, the legacy database leading to outages. Another thing is the service was over-provisioned to just mitigate any issue, and especially these outages. Another one was blockers. We were unable to provide any complex search, and also query performance was not quite well. And one of the biggest issues, adding any new feature was like it was like so difficult. Why? Because we had that SQL database that was not so easy to add any new feature. So it can kind of delay us to bringing any business value to our overall platform. Another issue is about, maybe it's a bit more domain-specific complexity, domain-specific problem, but it was a complexity. We have the confusing architecture with multiple sources of tools for that specific service. So, as you see, these are our challenges to scale. So when we think about solving a problem, and we are not only looking at the problem, we are not looking only at our challenges, we also need to consider our future requirements. So, what are our future requirements? So first, we want to have like a service, like any other service, any other places. We want to have a highly available, reliable, and a scalable service. We want to be able to handle the traffic for us, and also we want to be able to meet our platform-wide SLA. Another one is that we want to have a strong foundation for this service. So we can have like a fast and performant queries. And also, we want to be able to have we want to be able to implement more complex search to our service. Another things about, for example, the response time, we want to be able to reduce that if it was possible. Another point I think about the requirement, which is important, I think, in terms of engineering, is that we want to have a design that enable our future growth. It is important in order of the expand, because the future growth is not only about the traffic, it's also about your business values that you want to bring you to your project, to your company. So the business values can be provided if we have that design that can enable us for that growth. And the other things that we want to kind of achieve to reduce the complexity. So we want to be able to decommission any legacy component that exists, so we have like a better platform. So looking at this future requirement and also the challenges that we have, what could be the solution? So the solution actually involves more than just migrating the SQL database to cloud native platform, but also it requires like a comprehensive re-architecturing of our entire domain. But why about this re-architecturing? So re-architecturing is about designing a system that can cope with the traffic better, and also it can meet our business requirements. And in order to able to have this re-architecturing enabled for us, we need to investigate the tools that infrastructure that can provide this this kind of that can help us to have that better design and implement the whole architecture. So now we know that the right infrastructure and selection of this right infrastructure can really lead us to have a successful design that can cope with our needs, that can cope with our traffics, and can provide what we wanted to have in terms of this specific service. So now that we know about this re-architecture and importance of the tools, let's have a look at what could be the tools and options, and what are the options that we can take a look for this specific problem. One of them is throwing more money at SQL. So what are the issues with that? We have the vertical scaling for that SQL was limited, and also it's so expensive. At throwing more money, it doesn't actually solving our fundamental problem. The other choice would be managed SQL in cloud, such as Aurora. So it's still inherit the relational limitation, and it's not designed for that distributed high-volume search in our service. And another one is NoSQL, such as Dynamo. In Dynamo, query flexibility is limited, and again, Dynamo is not completely suited for search-heavy queries. So all these options doesn't seem quite work well for us. So in terms of tools and in terms of our service, which was a search-heavy service, we decided to go with OpenSearch. So what is the OpenSearch? OpenSearch is a search engine which built by Lucene Search Library, and it is a distributed, community-driven, and 100% open source search platform. And also, actually, AWS OpenSearch by AWS make it easy for us to deploy, operate, and scale this platform. So that is why we kind of feel like that, okay, it could be like a good option for us. And in terms of AWS, in terms of AWS OpenSearch, one thing that I would like to kind of point now in this time of presentation is that I'm going to go a bit, not like usually, a bit deep to how OpenSearch is working. So while we are moving forward, we have some kind of knowledge about how everything is there. So in OpenSearch, we have our cluster, and the cluster structure is kind of consists of multiple nodes that are working together, and each one of them has different roles. The master node, which kind of manage the cluster states, and also data nodes with store and manage the data, and it also handle the search and indexing process. and coordinating node that delegate the client request to the shards and the data nodes. Another part that I would like to talk about is about data organization of OpenSearch. So OpenSearch, as it is like a search engine, it is storing the data in terms of indexes. So indexes is like a logical collection of documents, and they are the basic unit by which the end user can store their data. So in OpenSearch, to distribute these indexes across the multiple nodes to achieve that scalability and availability, they divide them, they break them down to multiple smaller units, which they call shards. So if you recall that, I think in previous slides, I mentioned that OpenSearch has built by Lucene Search Library. So these shards are actually equivalent to the Lucene index in the Lucene Search Library. And also these shards also again subdivided into the smaller units which called segment. And these segments are file system which they created and they are this file system that whenever the data ingested to OpenSearch, the data can be created into these segments, and whenever there is a search operation, the search operation performed in the segment level. So this is how also we have the data organization of the OpenSearch. And now that we have a bit of knowledge about that, how data organization and how the cluster look like, let's quickly have a look at how the search request is going to perform in OpenSearch. So whenever there is going to be a request to the OpenSearch, the coordinator identifies the shards and send the data to that, send the request to that shards to provide the response for that specific set of documents. So also another point is that the search request can send to the shards or even to the primary shards or even to their replica to provide that availability. And each shard will get those requests. They are going to run the search locally to get the result, and then they send the result to the coordinator. Coordinator will wait for all the shards to get back the response, merge the response, and then go back and respond to the client. So now we know our problem. Our situation was a search-heavy service that we want to migrate, and we choose the tools, which was the OpenSearch. But what the next step, it was to choosing the right infrastructure. So to selecting the right infrastructure, in AWS, we have serverless and provision option as the two options for the OpenSearch that we can choose from. So let's have a look at a bit of comparison. So scalability, the serverless option can, in AWS, we didn't have do anything for that. It can be just provided by AWS, while for provision, anything should be handled manually. For resource manager, it's fully managed by AWS for the serverless option, while for provision, it needs to be managed by the user or the engineers. Another option, the maintenance. There is no maintenance requirement for the serverless, while provision, again, it's required the regular maintenance. Availability, again, it's managed by serverless, but for provision, it requires configuration and management. So in terms of configuration, I would like to mention that when we are talking about provision, we need to configure and set up this whole platform, this whole system, in order to cope with that traffic. And everything is in our control to configure it in a way that can work for us. So that is why if you want to have availability, maintainability, and all those things, everything is on you to do it and to configure it in a way that works for you. So finally, the cost. In serverless, we are going to pay per usage, but for provision, we are configure it. So we are going to pay for that configuration. So if your demand is high, so you are going to configure it for that high demand. So you are going to pay in that base. So it is the kind of comparison that we had. So obviously, so far, as we can see, it seems that serverless option is a good option. We need to go with this infrastructure. Why not? So let's have a look at how does the infrastructure of the OpenSearch serverless look like. So OpenSearch serverless separate the indexing and searching functionality to two completely distinct components. The indexing process is completely, as you can see, decoupled from the search component and also decoupled from the S3, which is the index storage. Whenever there is going to be a search request, it is going to go to the search computing unit. Search computing unit is going to download the file from the S3 if it doesn't have it actually cached locally, and then it's going to do the search on that file and respond it back. But when there is going to be indexing, it's going to indexing compute unit. Indexing compute unit is going to write it to the index and then send that index to as a file to our S3. So it is how the OpenSearch serverless architecture is working. But in order to assess that, okay, if this solution is right or not, we should not just stand there and look at the infrastructure and say, okay, that's it. We need to make sure that it is and it's also working for your specific use case. So what we did was make sure to load test this scenario. What was our step for this testing? We preload the OpenSearch with the necessary data for our queries as much as we need for that specific use case. And we simulate the production-like query with the same frequency as the production. So we try to simulate the same process, the same kind of queries that we have in production to make sure that we can assess by this load testing that if the serverless infrastructure could be a good option for us or not. And the result, also just I want to mention that on the right-hand side, I couldn't kind of put all the load testing option and all the picture that we have in terms of our load testing in one slide. It's just like one example of one of the endpoint in one of the load testing tests. So it's not like the whole of them. But overall, about the result, the index latency was reduced by half compared what we had in production. But the query latency increased by 2 to 7 times more than what we currently have on production, which doesn't seem too good, especially for the search-heavy service. We want to have like a very good search response and very good query for that. So the serverless doesn't quite provide for that. And within the standard, we have the communication with AWS instantly. So we communicate with them, talk about our issue. And one of the results of this communication was that we were depend on the fix that AWS have to do on the OpenSearch serverless. So we kind of see that, okay, if that's going to be like a good option for us or not. So we wait for that fix, and we run our test again. As you can see, the endpoint A, we have the result for one of our endpoint before the AWS fix. But after the AWS fix, we again run those tests, and okay, there was some difference, but although for some of the endpoint it was even much, much better, but although we have some improvement in the latency, it doesn't, again, kind of support what we need, and it doesn't kind of have the expected scale for us. So it doesn't work so well for us. But why we are seeing this issue? What was the issue here for us? So the first was a traffic pattern. Serverless, actually, as we discussed it, it seems that in that earlier stage, it was more fine-tuned for logging use cases with some predictable loads, and which for us, we had some sudden traffic surge for that specific service, which doesn't cope well for us. Another option, another kind of issue with that one was the scaling policy was issue that we had. There was some mismatch with the scaling policy. What we see was that the serverless scaling policy was not well aligned with what we need for this traffic surge in our traffic pattern. So it wasn't quite go well with that rapid scaling that we had. Another one was a scaling trigger. So this, again, a scaling trigger like the scaling policy, it doesn't work well for our use case and for our traffic surge. But final note was the earliest stage. The service was also its earliest stage, so it wasn't yet fully optimized for our unpredictable loads use case, and so because specifically it was something specifically for our specific service, so we see that, okay, it doesn't seem quite go well with our service. But we didn't stand there, so we thought that if serverless is not an option, let's have a look at the provision. So the provision architecture is a traditional setup, a single cluster instance that is responsible for both search and indexing. And also it has a data storage which is closely so tied to the compute resources. And again, we have the provisioned option, and we didn't again stand there. We do the same load testing, and the step was the same. We preload the OpenSearch, and we simulate the production-like query with the same frequency as our production, and the result seems to be quite good. So the indexing latency was reduced by 1/5 of our current traffic in production, and query latency reduced slightly, but one good point was that query latency for our complex search request was reduced by 1/5 compared to what we have in production. So it was quite good because the complex searches is most of the time is the one that is going to take a lot of resources. And that was that was the time that we decided to go with provision. So provision infrastructure actually handle our traffic scenario much better. And also provision instances offer the consistent and predictable performance. So why? Because we designed it to do that way. We configured the whole OpenSearch in a way that can cope with our traffic much better and can work especially with that unpredictable traffic search for us. And finally, we have the great control on our scaling policy and also allows us to pre-scale and handle the sudden surge much better. Also in this picture, as you can see, we have this green line, which is the latency for different queries that we have in production. The dark blue one on top is the result that we get from the serverless, and the orange one is the result from provision. As you can see, provision, although some of them it was so aligned with our production, but for some of those queries, it performed much better. And we know that if we want, we can configure it to perform even much better than this, but it was quite acceptable for us until now. But so far, does it mean that serverless is a disappointment? So of course not. Actually, while serverless actually brought its own set of challenges, and it also provides some valuable insight for us, so we can kind of implement there for our future kind of project. And as I mentioned, it's not a disappointment. It just means that it was a specific use case that it doesn't cope with that one. And if I want to have some of the takeaways for that is that, so the design and decision on serverless option or provision, it actually needs the specific domain knowledge and also the knowledge of a scaling pattern, which I also want to add the knowledge of traffic pattern probably. So why is that important? Because per service, the pattern that you have for your scaling about your specific domain. That, for example, for some, when you know about your domain that it has some sudden surge, it has some unpredictable load. So it's, while knowing those knowledge, it can kind of guide you to find some different option or some different kind of way of solving your problem, or even it can open up some other option for you. So it is important to have this knowledge while you are deciding on your infrastructure. Another one is that the technological selection should be driven by the unique use case and also the result that obtained by the testing. So for our use case, we do this load testing, and while we're trying to mimic our production, because our production traffic was something that it was important to us, and we want to make sure that we can cope this, when we are using this infrastructure, we can cope the same scenarios as the same way that production is providing for us. So that is why we are, I think that when we are looking at this, having this load testing and thinking about your specific use case could be an important thing. And finally, while the new technologies can appear so promising, it is always essential to assess their readiness for production and consider their potential kind of complexity or challenges that they might bring. So it is also important, for example, for our use case, OpenSearch Serverless was quite new, and we try to use that one and we try to test it and make sure that it is working for us or not. But we faced some difficulties, and that was something that it kind of, for me at least, is like a takeaway. If you are choosing a new technology, always try to assess and make sure that it is a good option for you or not. And by that, I'm going to thank you all to bear with me till now, and that's it.